5. Let's start with the statement. The graphs of f of x and g of x are drawn below. And from the equation, together with the graphs, we can see that the graph of f of x is a graph of a quadratic function, a parabola, and the graph of g of x is a hyperbolic function. A point of intersection of f and g is b, the turning point of f. So the turning point of the parabola is at point B, and at point B, that is where the graph of f and g intersect. And then the graph of f has x-intercepts at -3 and 0 and 5 and 0. Those are the x-intercepts of the parabola, the graph of f, and the graph of f has a y-intercept at point C. Right, question 5.1. 5.1, we have to write down the coordinates of the turning point of f. Which are the coordinates of b? What will be the coordinates of b? When we look at the graph of f, which is the parabola, it is in the form y is equals to a into x minus p all squared plus q. And if our quadratic function it is in this form, we know that the turning point will be given by p and q. Therefore, on the graph of f, what will be the coordinates of the turning point, which is point B? It will be 1 and 8. That is the turning point of the coordinates of the turning point, 1 and 8. Question 5.2, calculate the coordinates of C. C is the y-intercept of f. So in the equation of f, let's find the y-intercept by letting x be 0. Y-intercept, where we see x, we substitute 0. Therefore, f of 0 will be equals to minus 1 over 2 into 0 minus 1 all squared plus 8. We are using the graph of f because C is the y-intercept of f, of which it will be equals to, use your calculator, you should get 15 over 2. Therefore, C will be a point where x is 0 and y is 15 over 2. That will be the coordinates of C. Question 5.3, calculate the value of D. Where do we find the parameter D? On the equation of G. G of x is equals to D over x. Then what can we do? What should we do to get the coordinates of D? One way is to substitute B. Remember, B is a point of intersection for G and F. Therefore, in place of x, we are going to substitute 1, and in place of y, we will substitute 8 and solve for D. So we are going to substitute point. We are going to substitute B. 1 is to 8. So y is 8 equals to D divided by x is 1. Therefore, D will be equals to 8 when we solve for D. Then question 5.4. 5.4, we had to write down the range of G. The range, G is a hyperbola. Therefore, we know that our range will be all values of y an element of real numbers, but is the range except the vertical asymptote. What is our vertical asymptote? Y is equals to 0. Therefore, y must not be equals to 0. That will be the range of G, our hyperbola, all values of y except 0. Now we are on question 5.5 and 5.6. Let's have 5.5. 5.5. For which values of x will f of x times g of x be less or equals to 0? Meaning we want where the product of f and y is negative or is equals to 0. So when can that happen? That can happen when f is positive and g is negative. Or it can happen where f is negative and g is positive. Alright, let's start with the first one where f is positive and g is negative. Let's start first with f. We want where f is positive. Where will f be positive? It will be the graph that is above the x-axis, the graph that is on the positive y-axis. So let me use red to indicate the part of the graph of f that is positive. Now, where f is positive, we want where now g will be negative. So g, you only concentrate on g being negative only where f is positive. So let's use a different color. We want now where g is negative, but only g is negative. We are only going to focus on g being negative only where f is positive. So let's have a border. Let's just have a border. Now f, the graph of f will be not the graph of f, the graph of g, it is negative on the left of the y-axis. You can see that on the left of the y-axis, that is where g is negative, but we want where g is negative and f is positive. Then we can clearly see that at this point where x is negative 3, between f is negative 3 and 0, between where x, between 0 and negative 3 along the x-axis, that is where g is negative and that is where f is positive. So it will be where x is less than 0 but is greater than negative 3. That will be where g is negative and f is positive. But the question said less or equals to. So now the question is, are we going to include 0 and negative 3? Let us start with what? With 0. Let us start with 0. Now if x is equals to 0, let us check. On the graph of f, where x is equals to 0, what will be y? Where x is equals to 0 on the graph of f, what will be y? Y will be at point C there, which is 15 over 2. And then along the graph of F. And then on the graph of G, what will be, where x is equals to 0, what will be y? Y, it is undefined there. Y is undefined because it will be what? The vertical asymptote. Therefore, we cannot have what? 0 being part of the solution because of the asymptote. Then going to -3. Now, on the graph of F, where x is -3, what will be y? Y will be 0 at the x-intercept. 0 multiply any value, or in this case specifically 0 multiplying the value of y on the graph of G, where x is negative. You can see from the graph that that value of y will be negative. Therefore, 0 times a negative value of y will be 0. So it will be equals to 0. Therefore, -3, we are including it in our solution. Because where x is equals to -3, y of f is 0. 0 multiplied by y of g, where x is -3, will give us 0. Then we get the equals to 0 part. Now let us look at where f is negative and g is positive. So we are only going to shade the part of the graph where f is negative, f negative, f negative. Then g positive. G positive, you only concentrate on g being positive only where f is negative. Only where f is negative. So looking at our graph, we can see that at the x-intercept of 5, on the right of 5, that is where f is negative, below the x-axis. F is negative, and to the right of 5, that is where g will be what? G will be positive. So we can also have our border here so that we can see clearly. We can have our border here, and let us indicate the part of the graph of G, G that is positive. G that is positive. So where G will be positive and F be negative, it will be on the right of the borderline. Our borderline, it will be what? The equation x is equals to 0. So this is going to happen where x is greater than 5. Where x is greater than 5, that is when G is positive and F is negative. Positive multiplied by negative, less than 0. So now the question is, are we going to include 5? Since we are having less or equals to. So again, we check where x is equals to 5. On the graph of f, what will be y? F, where x is 5, x-intercept, that is where y is 0. So 0 multiply by the positive value of g, the positive value of y in the graph of g, where x is equals to 5. 0 multiplied by that value that is positive will give us 0. Therefore, 5 will be included in the solution. Then that is when now we can say what? X is greater or equals to 5. Therefore, this is how now we write the solution. This is now how we write the solution. So for 5.5, we can say our solution will be where x is less than 0 but greater or equals to -3. Remember, we said -3 is this included here. Or it will be where x is greater or equals to 5. Then question 5.6. Question 5.6. We have to calculate the values of k so that h of x is equals to minus 2x plus k will not intersect with the graph of g. We have the graph of g, which is a hyperbola, and the graph of h, which is a straight line. So one way of looking at this question is that we need to find the values of k where the graphs will not what intersect. But the question is, what will happen when they intersect? When they intersect, that is where h of x will be equals to g of x. That is when the two graphs will what? Will intersect. So now, what is h of x? H of x is minus 2x plus k equals to, and then our g of x, d over x, we have calculated the value of d is 8, therefore it will be what? 8 over x. So now, multiply both sides by x to get rid of the denominator, that x in the denominator, so we'll have minus 2x squared plus kx is equals to 8. Then we have minus 2x squared plus kx minus 8 is equals to 0. Now, this is when now we are seeing what will happen when they intersect. Then you see that we end up with a quadratic equation that is having the parameter k. So now, if you remember from your nature of roots, where you need to determine the values of the parameters, maybe where the roots will be real and so forth and so forth. So now, the question said we need to find the value of k so that h will not intersect with g. So how did we get this quadratic equation? We got this quadratic equation by saying what? H will intersect with what? With g. But now, if h will not intersect with g, it means what? It means the roots, thinking of it in terms of the nature of roots, it simply means what? The roots will be non-real. The roots will be non-real. It means what? There will be no intersection. Therefore, the roots will be non-real. Roots being non-real, that is where the discriminant is what? Is less than 0. So, taking the quadratic equation, let's further simplify it by multiplying throughout by minus 1. I always prefer to have my coefficient of x squared in an equation being positive. 2x squared minus kx plus 8 is equals to 0. So now, what is the discriminant? Our discriminant is given by b squared minus 4ac, which will be equals to, what is b? Coefficient of x minus k all squared minus 4 times a is 2, and then c is positive 8. Therefore, our discriminant will be equals to, simplify, we get k squared minus negative 4 times 2 times 8 will be negative 64. Now, this will be our what? Our discriminant. When we are solving the equation of h and g simultaneously, this is the discriminant. But now we are saying what? We don't want h and g to what? To intersect. It means what? It will be where the discriminant is less than 0. The two graphs will not intersect. There will be no roots in the language of nature of roots. Therefore, we are saying this will happen where k squared minus 64 is less than 0. Then k squared minus 64 less than 0. Now we are now looking at what? Quadratic inequality. So we can solve for k the same way we solve quadratic inequalities. We can say find critical values. K squared minus 64 equals to 0. K is equals to 64. K squared is equals to 64. Square root on both sides. K will be equals to plus or minus 8. So let's take it this side. Therefore, k is equals to 8 or k is equals to negative 8. Then we draw our line. Then we are saying k negative 8, k positive 8. Then we draw our parabola. And then from there, before finding the critical values, how is the inequality? Less than 0. Less than 0 means what? Below the line. Below the line. In this case, it will be this part of the graph. And it's just less than 0. Therefore, negative 8 and 8 are not part of the solution. We use open circles. Therefore, our solution will be between negative 8 and 8. It will be where k is less than 8 but greater than negative 8. So this will be the values of k where h and g do not intersect. And the last question on question 5, question 5.7, h is a tangent to g at a point r, a point in the first quadrant. Calculate t such that y is equals to f of x plus t intersects g at point r. So we know that there is a point in the first quadrant, which is point r on the graph of g, our hyperbola. And then h, which is we're given the equation of h in question 5.6, h of x minus 2x plus k is a tangent to r, is a tangent to r. So if maybe we are to just visualize, let's say if maybe r, let's say r, maybe it's a point somewhere here, it's point r, then what will be h, the equation of h? This will be the equation of h. Roughly, this will be the equation of h. So now we have to calculate t such that y is equals to f of x plus t intersects g at r. So now firstly, we need to determine the coordinates of r. The coordinates of r, which is a point of intersection of h and g. We know the equation of g, but we don't know the equation of h. Remember, h of x is equals to 2x minus 2x plus k. The equation of h is h of x is equals to minus 2x plus k. K not 18k, meaning we need to find the value of k. What will be the value of k? Now, from question 5.6, we said k will be between minus 8 and 8 when the graph of h and g do not intersect. So now, if the graph of h and g do intersect, it means what? K will be what? K will be greater than 8, k will be less than 8. In terms of the when we're using what the discriminant, meaning the discriminant now will be greater or equals to 0. Now it would mean when we draw the graph of h when k is equals to 8, we are going to get roughly this blue graph. And when we have to draw the graph of h when k is equals to minus 8, we will roughly get this this red graph. So you will see from 5.6 they will not intersect in between. You will see in between there will be no what intersection. That is where hk is less than 8 but greater than minus 1. But now there is a reason why in this question specifically they said a point in the first quadrant. It is because the tangent h being the tangent to the graph of what? Of g, it can be what? At 2 points. Here at point R and also at this point, let's call it point point W. That is the other tangent that we can have where k is equals to minus 8. So we are only going to be concentrating on first quadrant. Therefore, what will be the value of k? In first quadrant, then we know that h of x will be given by minus 2x plus 8. Now h will be a tangent to g in the first quadrant when k is equals to 8. So now we have the equation of h. So now we can determine the coordinates of r. So r for r it will be where h of x is equals to g of x. That is how we find the coordinates of r. That is where the graph of h and g intersect. What is h? Minus 2x plus 8 being equals to g is given by 8 over x. And then now solve for x, multiply both sides by x, minus 2 x squared plus 8x is equals to 8 minus 2x squared plus 8x minus 8 equals to 0. Then divide throughout by minus 2 x squared minus 4x plus 4 will be equals to 0. Then we'll have x minus 2 multiplied by x minus 2 equals to 0. Therefore, x will be equals to 2, or x is equals to 2. Therefore, we only have x is equals to 2. This will be the x value of r. Now, how do we find the corresponding y value? We can use the graph of g, but we want where? We want the value of y for g where x is equals to 2. Therefore, g of 2 will be equals to 8 over 2, which will be equals to 4. Therefore, this means the coordinates of r will be 2 and 4. So now we actually need only the x value of r, but it's fine. So now we go now to the question. We have to calculate now t, such that y equals to f of x plus t intersects g at r, meaning where y intersects g at r, it means y will be equals to g of x, where y is equals to g of x at r. What is y? Y is f of x plus t. What is f of x? F of x, our quadratic equation, minus 1 over 2x minus 1 all squared plus 8. But remember, we are at point R. So at point R, y will be equals to f of 2 plus t equals to, and g of x at point R will be g of 2. Therefore, what will be f of 2? We substitute 2 in place of f in the equation for f. So we have minus 1 over 2 into 2 minus 1 all squared plus 8 is equals to 8 over 2. Then we have, on the left hand side, we still have plus t. We have plus t. Plus t is equals to, on the right hand side, 8 over 2. So on the left hand side, when you simplify, you will get minus 1 over 2 plus 8 plus t. On the right hand side, we have 8 divided by 2 will be equals to 4. Therefore, solving for t, minus 1 over 2 plus 8 will give you 15 over 2. Then solving for t, 4 minus 15 over 2, you must get minus 7 over 2. That will be the value of